like last term, all classes were group projects, final projects.
Mm.
So you can very easily see who's actually. No.
Okay. Yeah, so today I think we're just going to do a little review of effects, of particle effects, because I realized we didn't so much skim over it as we only kind of covered the basics, but we're going to cover some more advanced concepts in our effects and just cover some additional tools that we can use to make our effects more believable. Okay. So yeah, we were doing the tornado, which is a pretty big, pretty challenging one to tackle. But let's just keep going with that. So we have our tornado here. And if I recall, the issue that I was having is it was kind of like really spreading out as it got higher up. Also having some issues with the color on our particles here. So that's something that we can go in and fix. And the way we're going to do that is by kind of binding the properties on our modules. So just to do a quick review of particle effects in general, I'm going to see if I can get this second monitor on too. Weird that it's not on. Let me just see if I can get that to work. Weird. I'll turn off the lights and we'll just use the one monitor, I guess. Okay. So just a quick review of particle effects. We have these red nodes here, and these are emitters, right? And what these do is they just create particles of different types. So in our case, rendering sprites, which are just these little images here, right? Or little dots of smoke. And what you select, and it's kind of each of these little tabs here are modules that add behavior to our particles. So they make our particles spin around, they assign color, they apply physics and gravity and all kinds of stuff. But we can also mess with the parameters of these things. So if I go in here and I select, scale color, I can mess with this here. You can see we have all of these parameters here that we can mess with. So I'm going to start just with this vortex force one. And so what I think the problem might be is that as the particle kind of lives longer, it gets thrown further and further away. So maybe I just want like less vortex force to be applied as the particle lives, right? So what I need to do is I need to bind this here to an expression. Right, so we have, again, I've just selected, you can select any one of these, it doesn't really matter. Just for the purpose of example, I'm going to show you this vortex force one here. And I don't know if this is going to work, but I'm just kind of guessing. Right, so we have this vortex force amount, and this controls basically how much spin we're applying to our particles. Next to each of these properties here, each of these values, we have this little arrow drop down, right? And if I select this, you can see we have a whole big list of different functions that we can apply. And I'm going to select this one here called float from curve. And if I select this, you'll see that my vortex force amount now has this little gearbox here. And so what I've done, this is called a dynamic expression. You can think of it just like a function, right? I've replaced this with the output of a function. And in this case, our function is this curve here, right? So going back to, high school math, we have this graph. There's a y-axis and an x-axis, and we have points on our graph, right? The curve index is how we tell it what point on our graph we should sample for what value, right? And you can see this here is also kind of replaced with this bound property, basically. And you see it's called normalized age, which is just to say, if our particle lives for 14 seconds, let's just use that as an example, or 10 seconds, it lives for 10 seconds. This will return 0 at 0 seconds, and it will return 1 at 10 seconds, at the length of the lifetime of the particle. And so you can see how it's changed the kind of spread, the application of our vortex force, right? Because our particles spawn here, and as they live, they go upwards, and as they live, less of that vortex force is applied, right? I'll tell you what I've told other sections, right? The point is not to know what all, like if I click here, the point isn't to know what every single function does. I don't have all of these functions committed to memory. I just don't. There's way too many. And even people who are much more talented than I am at this don't know what every function does. The way you figure out what to do is you look at reference. So again, I looked at my tornado and I said, well, the problem is it's spreading out too much at the top. And then I kind of guessed, okay, well, I just need to kind of control when and where I apply vortex force. And then I clicked this drop down and I just kind of guessed which one I should pick, right? So I said, okay, as the lifetime of the particle goes on, apply a little less vortex. Okay. We can add keyframes here. So in our case, we're going from 0 vortex force at the bottom. So if I look at the bottom here, I can see it's actually not even spinning anymore, which is a bit of a problem. Or it's not spinning a whole lot. So I might just take this up a little bit like so. And we have this other property here that's called a scale curve, which is just multiplying the values of the curve, right? So if I want this, right? So this one here at time 0 is returning a value of 1. If I want this to return a value of 1000 instead, I can scale my curve by 1000. Or what was it? I think we had like really high value, like 50,000. Maybe that's a bit too much. And we can just kind of scale it down as the particles live. Right? And again, this might not even be the right answer, but I'm just kind of guessing. Okay. We could try the same thing here. Like we have this vortex origin where we kind of pull the particles towards the origin here. And we have this thing called a simulation position, right? So this is like the position of the emitter. I don't know why this is taking so long to compile. Right. And you might not get the right answer the first time that you try this, because I'm looking at this and just trying it, and it's not giving me a perfect result. But the takeaway is you have these drop downs, and you can kind of replace them with the output of functions, right? might do another example, a simpler example, just to give you a better idea of how this works. By pulling it towards the center to see what happens. Yeah, I might have to come back to this. Pull originality, pose on a vortex plane 3D, give you a stable rotation plane. See what that does. Because there's probably even a better way to do tornadoes than with sprite renders. Okay, that's actually not too bad at all. It's a little better. Anyway, that's the gist of it. Okay, let's do another example. I'll do the example I've done for other classes. The reason I did a tornado for this class is, I believe someone mentioned a tornado. It's kind of fun, but the example I've done for other classes is like an electrical beam. So let's try another type of particle. So again, the way we create a particle is we can come in here and create a Niagara system like so. And we'll say a new system from selected emitter. And we have all of the parent emitters. So all the emitters we've created, you could use one of those, but we're just going to pick a template. And I'll show you guys a bit more of an advanced, because we already have the basics of particles down. I'll show you a bit more of an advanced application of materials here. So we have this dynamic beam right here. I'm going to select this. I'm going to add a dynamic beam to our system and just click Finish to start. I'll call this FXS, electrical beam FS2. If I double click and open this up, the main difference you're going to see is that this is obviously not just like a single sprite. It's not a little dot. It's a beam, right? We have this thing down here called a ribbon render. So instead of a sprite render, like if I go back to my tornado, you see we're rendering a sprite, and here we're rendering a ribbon. But other than that, like aside from the fact that we're rendering a beam instead of a little sprite, it's largely the same. We have this red node here with a whole bunch of properties here that control how our particle looks and behaves. Okay. So one thing, if I want this to look like an electrical beam, I might want this to glow, right? So I have my color here, and you can see it's set to this like blue color here, and that's matching right here. If I want this to glow, all I need to do is take this color value above a value of 1. So I'm just going to set my blue value to 1,000. This is weird. It's not very well documented, but that's how you make something glow with a particle. However, this isn't great because I don't have a lot of, it's kind of hard to control the exact color that I want. So I might want to kind of abstract out the color and the glow of my particle, right? So I can go here, right? I have my drop down. And I'm going to select, I just search for multiply linear color, right? So this way I can set my color here and then multiply it by an amount that I want it to glow, right? Because if I have say I want my electrical beam to be red, I can set it to the red to 1, green and blue to 0 and 0. And if I want the red to be, say, 1,000, I want to, like, what do I need to multiply a value of 1 by to make it a value of 1,000? 1,000, right? 1 times 1,000 is 1,000. So we can go to our scale factor here and multiply it by 1,000. Now it's glowing red. But maybe I don't want to have to multiply each channel individually, right? So if I set this to a value of like a yellow color here, you can see if I want this, if I want to multiply both the red and the green channel, I'd need to come in here and multiply both like so. So maybe I just want a single value to control all of the channels here. So I multiply this entire color by kind of one float value. I can come here and I'm just going to search for float because I don't know. Because I want to use a float. Just search for float. Maybe we'll get something that gives us a float. And right here we have make vector 4 from float. Now we have a single value and you can see, right? So you can see we have just these little gearboxes here that are replacing our properties with functions. And these functions have more inputs that you can replace with the outputs of other functions. And if we want to replace this float value here with the output of yet another function, we can do that, right? I just want to try something. I'm probably going to get rid of it after, but maybe I want my electrical beam to steadily reach like a glowing point over its lifetime. So I want it to start invisible and then glow as time goes on. Right, so I can just plug in 10,000 here just to show that this is working, that it's multiplying everything. Maybe I can, okay, here we go, multiply float. So now I can replace this float with the output of a multiply float. And I'm going to have this, I'll say this be like 10,000, right? What I'd like is for this to kind of, again, kind of ramp up. I want it to start not glowing and then glow by the end of its lifespan. In addition to these functions, we have these things called inputs. And if I go here, these are kind of like variables that live inside of our particle system. So you can see here, if we want to do something based on the weight, the mass of the particle, we can do it here. We can do it based on the ribbon width or the length. But I'm just going to pick this normalized age property because we've already used this, right? And select normalized age. It'll take a second to compile. And it kind of glows brighter and brighter and brighter as time goes on. Okay. Again, this is by far the most complicated part of our technical art course. I'd say materials and 3D models are generally pretty easy if you just kind of follow the tutorial, follow the lecture. You can figure those out. They're not terribly difficult. Particle effects require an artistic eye. You need to think about the particle effect that you want to create, and you kind of need to guess at how you want to make it. You need to look at reference and kind of think, what am I actually looking at and how do I express that as math? Okay. I'm just going to get rid of this, this multiply float here. If I want to get rid of something, I can just click on this little arrow here to reset to default value. So I'll just click on that. And you can see it's just reset it. It's got rid of that expression. And I'll just keep this at a value of 1,000 so it keeps glowing. Okay. When I think of an electrical beam, right, like an electrical arc, is it perfectly flat like this, or does it kind of bend and wobble, right? It goes all over. So we need to maybe find a module that will make this thing kind of bend and jitter and change its position. I can click on the plus button here to add modules. We've kind of gone through adding modules here. Maybe I don't know, again, I don't know every single module. I'm just going to search for position, right? Because I want to change kind of the position of my ribbon here. And we have this one here called jitter position right here. And you can see it says jitters a particle in a random direction on a delay timer. I'm just going to select that one. Oh. Okay, so maybe my glow is just a little too much, so I'm having a hard time seeing what I'm doing. I'm just going to take this down like so. Now, if I look at my jitter position, there we go. Okay. Now we have a kind of jittering electrical beam. I'm going to show you how to kind of blend our coding knowledge with our particle knowledge now, okay? I'm going to create a blueprint. So I'm going to go to Blueprint class. And I'm going to just make it an actor, because this is going to be something that we place in the scene. And I'll call this BP underscore electrical beam. Okay. This makes sense. I've just created a blueprint. I'm going to double click and open this up. So we should have our particle system and our blueprint here. We can add a particle system as a component of a blueprint, right? We've gone over components. We've used collision. We've used static meshes. But I believe right here up at the top, the common components, we have this Niagara particle system component. Add it in. And I'll call this electrical beam. Okay. And here with this component selected, you can see it's saying, well, like what system do we want to use? It's just a property. It's a variable that we can set. And I'm just going to choose my electrical beam underscore FS2 right here. And now you can see we've got our beam right here. Okay. We can pass properties from blueprints to our particle systems in real time. Okay. So I'm going to go to my event graph here. And I'm just going to click and drag my electrical beam into my event graph here. And then I can click and drag, and I believe it is set Niagara variable. And we have this whole thing of like set Niagara variable by string. And you have all of these kind of types in brackets. And so in my case, what I want to do is I want to have a blueprint where I can have kind of, call it this position A and this position B. And I want to have like an electrical beam that just runs between these two positions. Right? So I want to be able to control where my beam starts and ends. So that's probably going to be a vector 3, right? That's a position, X, Y, Z, right? Because position A is going to be X, Y, Z position, and position B will also be an X, Y, Z position here. So I'm going to say set Niagara variable. And we have this one here, set nag variable vector3. I kind of like this one, nice and easy to use. I'm just going to plug this into event tick for now. But the question is like, well, what's our variable name, right? How do we define a variable in here? Okay. Depending on what your screen looks like, you may have this parameters window kind of down here at the bottom, right? Or you might have them all in tabs up at the top. When I have a bigger monitor, I can see both my preview and my parameters at the same time, but because I'm using a smaller monitor, I only have tabs. You should have this parameters tab right here. And if you don't have that, you can go to Windows and should have a user parameters and a parameters tab here. So if you don't see this, go to Window and make sure that this is checked. Okay. And we have this, you can see all of these parameters that are provided by the particle system itself, all of these attributes that, you know, the particle system just creates. Then we have this tab up at the top for user exposed. So let's expose a parameter. I'm going to click plus. You can see here it says make new, common, and you can see all of the kind of common data types that we can create. A lot of these you don't need to worry about. Like typically I almost never use matrices. Sometimes I'll use quaternions if I'm doing like very specific rotation stuff, but we're just going to create a vector here. And we can call this beam start. And I'll create another vector. Common vector. We'll call this beam end. Beam start and beam end. So we've just created two variables on our system. I'm going to go back to my blueprints here, and I can see I have this in variable name. I'll just call this beam start. And I can just copy and paste this node. We'll call this beam end, right? Now, right now, the value, this in value here, is what we're actually overriding and setting the variable to be, right? If we set the beam start and the beam end to be a value of 0, 0, 0, it doesn't really work, does it? So I'm just going to promote these to variables, right? Remember how to do this. We click and drag and release and promote to a variable. And I'll call this variable beam start. And I'll call this variable beam end. And then what I'll do is I'll make them visible. So I'll click the two little eyeballs next to the variables in the list. And I'll show you a fun thing you can do with vectors. So with my vector variable selected, so beam start, we have this toggle in our details panel called show 3D widget. I'll set that to be true for both of these. Now, right now, this doesn't really do much, right? You can't really see the widgets. So I'm going to drag this into the world. Right, so I have my level here. I'm going to grab my BP electrical beam blueprint and just drag it into the world right here. And if I have my blueprint selected, now you'll see that there are these two little diamonds that you can select. And so you can just manually move these around and set, and you can see the beam end variable here is updating to match the position of where I move this little diamond. Okay, so you can manually set your variable like this. So ideally, I would like my beam to kind of connect these two little diamonds that I can now move around once I've placed this blueprint in my world. Okay. So I'm going to go back to my particle system here, right? So we've created our little widgets. I'm going to go back here. And here we have this module called Beam Emitter Setup. And we have this beam end property here. Right now, it's just set to 200, 0, 0. I think I can actually just click and drag from my parameters list here. So I can click and drag my beam end. And you can see that it's highlighted and I can override it this way. Or you can click this drop down and search beam end. I'm going to hit compile and save. Now, if all has gone well, it should update, but as you can see it now, the beam start and the beam end are kind of locked into the same position. We no longer have our electrical beam. I'm going to go to my blueprint again. You can see it's the same problem here. What I'm going to do, right? So here we have on tick. We're connecting these two variables like so. I'm just going to select all of this and right click and collapse it to a function. And we can call this function update beam. And then I'm going to go to this other tab here. Now, I don't know if I went over this tab in detail for this section. Every section has asked different questions, resulting in kind of different lessons at different points. But we have this tab here called a construction script. And all I'm going to do is I'm going to call this update beam function in my construction script. I'll hit compile and save. And now if I move around this beam end here, it now connects. You look confused. You're giving it some side eye. What's going on? Okay. So let's see if we can fix that issue. So let's open up our beam particle system here. We have our beam emitter setup, and we've set the beam end to beam end. I'll open up this update beam function. You need to be very exact with the variable name. Like it needs to match perfectly. Case sensitive, everything needs to be right. With our kind of electrical beam component set, we've set it to our electrical beam system here. We have our beam end variable. We've plugged our beam end variable in here to the in value of this set. And we have this show 3D widget thing enabled here. And once we've placed it in our world, we have this little diamond that we can move around. And you're saying the beam has just disappeared. Is it working? Good. Okay. Let's do the same thing with our beam start. So I'm going to go back into my particle emitters here. We have our beam start. We can do the same thing with our beam start variable. Just click and drag that there. I'll hit compile and save, and we'll see what could be going wrong here. Save. Okay, we have this toggle here for absolute beam start. I'm going to set that to false. Absolute beam start. We'll set that to false. Not actually sure what absolute beam start and end do. It's a good question. Oh, okay. Now we're getting somewhere. Now I can at least see my beam. Beam start set to 0. Now if I select my electrical beam, you can see, yeah, it's kind of flying all over the place. Where's my beam start and end variables here? There they are. If I move this around, so that's sort of working. And if I move my beam end, so now the beam start is working, but the beam end isn't. So let's debug this a little bit. I'm just going to try using absolute beam end. I'll toggle that to true and see what happens. And this is kind of the unfortunate thing with particles, is it, unlike most things in Unreal Engine, which are fairly well documented, if you hover over any of these properties, it does not tell you anything about what it does. I select absolute beam end. Absolute beam end. Interesting. So the beam start is working, and now the beam end is not working. Am I missing something? Is my next question. This is where I just double check and make sure that my functions are working. Beam end is set to be true, show 3D widget. Okay. So this would be my guess for what the problem is. And this is just a guess. So my beam start is working fine, but my beam end isn't. So what I'm going to guess is that my beam end and my particle system, we're kind of losing something in coordinate spaces, right? So I'm going to guess, and again, this is just a guess for debugging. My beam end is getting a position, is expecting a position in world space, but it is getting a position in local space. What does that mean? All it means is that if I select this electrical beam component here, you can see that its location is 0, 0, 0. And that's because every object in Unreal Engine at some level assumes that it is the center of the universe, right? Every object is selfish, right? So this has a location of 0, 0, 0, even though relative to the world, to this, like the world itself is the center of the universe, this is its position. So I'm going to guess that when we tell it, when it comes to the electrical beam, when we pass that variable to it, that there's something just kind of messed up happening there. So I'm going to guess. I'm not sure if this is going to work. So I'm going to go back to my electrical beam into my function here. I'm going to add to this. I'm going to say get world location. And we can do it for our electrical beam. The other one, I believe, is get actor location. Get actor location right here. I'm just going to add them together and see what happens. Okay. Getting a little bit closer, but still not quite. Okay, I did this example for another class and I didn't have this issue, so I'm kind of wondering where I've gone wrong. Try subtracting their position instead. I didn't even have to do this math for the other section. All me curious. I'm going to try one last thing. I'm going to set both the beam start and beam end to absolute. I wish it would just tell me what it does. Absolute beam start, absolute beam end. And that's definitely not working. Okay. Kind of curious why that is not working. I'm going to double check this one last time. Absolute beam start, absolute beam end. So it was working when the beam start was set to the So reset this to default values. Working when this was set to the simulation position, returns either the owner position or the local 000. So this was working. And we ran into an issue when we tried to override the beam start with another position. Start. Beam start, beam end. And I'm just going to double check to make sure that my variable names are set correctly, because that's another possible issue. I'll also try the same thing I did here. Go to viewport. Can I mess with the beam start? So that seems to be working when I set it here. So it's working in the viewport here, but it does not seem to be working in the world. Whoops. Okay, so I might have to go back and figure out why the beam start isn't working, because probably just missed a step that I did with the other section. There is one other toggle that we can check. So in our electrical beam, we have this thing called use beam tangents. That might be the issue here. Although I doubt it. I don't see why it would be the issue. BP electrical beam. No, I doubt that that was the issue. Okay. So we're just going to leave this. I'm just going to reset this to the default position for now. And I'll double check why exactly this isn't working. The takeaway I hope that you pull from this is you can pass variables from blueprints to your particle systems to kind of control the behavior of your particle systems at runtime and kind of get a more dynamic effect. Okay. So I just zero these out for now. Grab my beam, and you can see that you can pass information, you can pass variables to your beam. We can do the same thing with our color as well if we're of a mind to. So I can go to my electrical beam here, go to my color, and I can create another user parameter here. Make new, common, and in my case, linear color. That's what I'm looking for. And I'll call this beam color. And I can click and drag and assign this to this linear color property here. Now, by default, it's going to be black or white, I assume. Yep. But we can do the same thing that we did with these other variables here. We have our electrical beam. We can set a Niagara variable. And we have leave a linear color right here in brackets, right? So I'm just scrolling up and down to see all the variables you can set. And we have this set Niagara variable linear color. And I'll call this one beam color and promote the value to a variable. Compile and save, and then we can set the default value here. I don't know, red. And I'm going to double check that I spelled everything correct. Beam color. Here, beam color. If I go in here and I select my electrical beam, I may want to expose this parameter. So I can go back to my blueprint and just click on the little eyeball to make sure that it's instance exposed. And I can go in and set my color to really whatever I'd like. I'll set it to this like blue color. And now you can see that my beam has changed from red to blue. Okay. That's the gist of passing variables from blueprints to particle systems, right? You can do the same thing with materials. I'll show you how to do that now. Not sure if your lab expects you to know how to use dynamic material instances, but it's kind of fun, so I'll show you how to use it. To do this, I'm just going to create another blueprint class. And it'll be of type actor, and I'll call this BP material instance demo, call it whatever. I'll open this up, and just to start, I'll add a sphere. So I just created another blueprint and added a sphere to it. Okay. And what I want to do is I want to be able to create a material and then set properties on that material at runtime, right? So if I go back to my materials here, and so this is basically the same idea that we did with our particle system here where we passed variables to it. We can also pass variables to our material here. So I'm just going to open up my basic surface. And you can see we have this tint and tint intensity parameter exposed. If you don't have these exposed, you can create a parameter. You can just use like metallic, specular, or your roughness value as well. That will work too. But I'm just going to use tint and tint intensity. So I'm going to go back to this material demo here. And on begin play, I'm just going to put it together in my event graph. I'm going to right click and I'm going to say create dynamic material instance. And we have this right here, create dynamic material instance. And it's going to ask you for a parent. So it's like, well, like, what material do you actually want to create an instance of? And if I select this dropdown, you can see you can pick kind of any material you want. I believe mine was just called basic surface. M underscore, and you can see I did the basic surface for a lot of them, M underscore basic surface. You can assign it an optional name if you like. Yeah, it's not really necessary. And then off of this return value, you can see that we can set parameter. I'm just going to search for set parameter. And you can see that we have kind of a similar set of functions. We can set a scalar parameter by value, set a scalar parameter by info. I'll show you both. I'm going to choose set scalar parameter value first. And this is the same idea. We have a scalar parameter. We'll call this one tint intensity. And again, it needs to match exactly what you've called your parameter. I can promote this to a variable. And I'll do the same thing. I can click and drag off of here and say set parameter. And I believe this one should be a vector parameter because it's a color, right? And this one I'm just going to choose by info to show you the difference. So this one, we just kind of pass it the name and it updates it. But this one expects a parameter info. And what I'm going to do here, just to kind of expand this a little bit, I'm going to right click on this parameter info struct pin, this blue thing here. I'm going to right click and say split struct pin. And you can see it expects the name, same deal. I believe it was just called tint. And this is more of an issue when we get into like more complicated materials where we're like blending and layering different materials. For now, we're just going to leave it at global parameter. And for our value, I can do the same thing. I can promote this to a variable and call it tint. And then what I want to do is I want to assign this dynamic material instance to my sphere. So I'm going to grab my sphere and I can just say set material, right? So sphere, set material, and I'll just click and drag my dynamic material instance into there for now. I may need to go in and clean this up and refactor it a little bit. That's doable, okay? And then just like before, I'm going to select all of these nodes, right click, and collapse it to a function. And I can call this update material. Okay. And I can go to my construction script and call my update material function, right? And if all has gone well, you can see the material on my sphere has now changed. Right, so I went to my construction script, called my update material function, which I made just by selecting all of those nodes, right-clicking, and collapsing to a function. So I'm going to look at my viewport here. Now, if I want to change my tint, I can grab my tint intensity variable here, set it to a value of 1. And you can see now it's tinted black. And I can change my tint color here. Value like red. Should probably be white by default, just because something tinted white is just tinted itself. You can tint it in kind of any color you want here in your blueprint. This is kind of the hello world of kind of linking code and art. Kind of what we did with our basic particle system and our basic materials, that's baby stuff. That's the intro. This is where things can start to get interesting. So for example, for your mini map, right? You were discussing that. You would have a dynamic material instance of your material that you're going to apply to your widget. And you would, I believe we can set parameter. On now, drag and release, set parameter. You can set a texture parameter value, right? You can override a texture. So you would generate, in your case, probably a render target from our runtime virtual texture. We can go over this in our review session later this week if you'd like. And you would use this same principle to create a mini map to do scorch marks on a surface. Like imagine you have a surface that is getting rained on and you want it to appear smoother. You would create a dynamic material instance and change the roughness of your surface at runtime, right? It's not the best way of doing it, but that's one way that you could do it, okay? We're kind of getting to the part of the course where like none of this is really necessary for you to do your assignments, but I think it's just kind of neat and it's kind of fun, okay? Questions about dynamic material instances or particle variables, like so.
Some way of like everything.
Yeah, the reason they do it that way is otherwise like each particle system would have to be like a child class of the parent particle system, if that makes sense. So when you kind of just set a parameter by name, each like we just have like one particle system class. This is our like FX particle system base class. And it has a dictionary associated with it, right? And this way, it's just kind of one function where we say, like, we'll set this property. It's going to look for whatever we set our variable to, like this, right? So like this dictionary would be for all of our scalar values. We'd have another dictionary for our float value, or not float, vector values, color values, texture values, mesh values, et cetera, right? And so this way, it's just kind of like it consolidates it into one function where you just kind of pass the key that you're looking for in order to override that value in the dictionary. As opposed to, our beam now needs to be a class that then has like a separate, we're now extending it with another variable, another property, which then if we wanted to interact with it, we would have to say like, okay, get our components, cast to a beam class, set the variable on our beam class, which like could probably work. It just complicates things, right? And this is especially true because a lot of studios will just have like a very consistent framework. So, you know, every single particle system will just have like a tint variable, for example. And this way, when you're calling that function, you can just be like, oh, well, like set tint, right? You don't need to be like, okay, fx cast, make sure that the subclass has the exact same property name and then set the property name that way. That's why they've structured it that way. And same thing with materials, right? Just because like there's one kind of material class, and then every material just has a dictionary of properties that you can overlay. Okay. That's kind of all I really wanted to cover today. I might just add some sparks to this electrical beam just to make it a little more interesting. So I'm going to go to my effects, go here, and this time I'm just going to create an emitter and just call this one, you know, FXE sparks. When we think about sparks and just kind of like how they move, they kind of just like explode outwards, right? So I'm just going to select this omnidirectional burst. If you hover over it, it'll tries to preview it. Usually it's better. For some reason, it's a bit janky right now. I can call this. So I'm just going to add this emitter. And you can see it's just kind of like exploding like this. And just to start, I'm going to go to my beam system here. Just going to close those down. Go back to my beam system. I have my dynamic beam. I can right click and I can add an emitter. So I can just add another emitter to our system here. And I'm just going to select my sparks emitter that I just created. So now if I look at my preview, I should have sparks alongside my beam, which is not doing a very good job just because we've kind of set it to just be kind of consolidated in itself. And if I press play and just watch this through, I might want these sparks to like keep repeating as long as the beam exists. So I can go back to my emitter. And for my emitter state here, we have this thing called loop behavior. So right now it's just set to play once and then it culls itself. It removes itself from memory. We can choose infinite, so it just keeps looping forever. And the next thing we have here is this spawn burst instantaneous. So what spawn burst instantaneous does is it just spawns 100 of something at a given time. So in our case, 0 seconds on our timeline, it just spawns 100 of our sparks. I'm just going to disable this item for now. I'm going to add a module called spawn rate. And I don't even need to search it. Like the most commonly used ones are up here at the top in the suggested tab. We have our spawn rate right here. And this one just spawns them at like a fixed number per second. So for my spawn rate, I'm just going to choose like 1,000. Right. I would say sparks don't tend to last so long. They tend to kind of like fly off and then like fizzle out very quickly. So I'm going to go to this initialized particle here. And for my lifetime min and max, I might just take this down like 0.2 and 0.5. Even then, that's still a little long, like 0.1 and 0.2. So between 0.1 and 0.2 seconds, that's looking a little better. And our shape location, yeah, that all looks right. Okay. I might want to double check one thing here. Shape location, shape radius, non-uniform scale, scale, rotate, offset. shape origin, stack context position. Okay, that's all fine. So I'm going to come here back to my system where I now have my sparks and my beam. I'm going to go to this shape location here. So you can see we have our emitter where we're just kind of like establishing what our sparks are going to look like. We can go back in and clean this up later. I'm just trying to get like the general kind of animated feeling of sparks more so than like every little thing down to the letter, right? Go back to my system here. So right here you can see we have our beam and our sparks. I'm going to go down to this shape location here, and I'm just going to try and override this property. Because what I want to do is I want this sparks emitter to emit at the end of the beam, right? So where the beam is like it's shooting out from something and it's hitting a surface, and that's where I want the sparks to be. And I'm going to guess it has something to do with this offset mode. I'm going to set that to default for a second. And now we have this offset parameter here. And I'm going to select my beam end right there and compile and save. We'll see if this works. Oh, we can actually set that to world position. That's new. Interesting. And there we go. Might want to fix the issue where my beam kind of like plays for a few seconds and then dies. But you can see now it's spawning sparks at the end of my beam. Yeah, so one issue I just want to fix with that is just the electrical beam kind of not living forever. Not sure how I'm going to fix that. So if I can go to lifetime mode, I don't think that's it. Maybe my emitter state, loop behavior is set to infinite, scalability mode. It's set to 3 seconds is the lifetime, but the loop duration is 4 seconds. So what I want, what's happening, the reason that my beam is disappearing is my beam has a lifetime of 3 seconds, but my particle emitter has a lifetime of 4 seconds. So there's always going to be a gap of 1 second where my emitter exists, but my beam does not, right? Because my beam dies 1 second before the emitter loops, right? So I could just be really disciplined and like go in here and make sure that this is set to 4 seconds as well. And if I hit compile and save, now it's looping, right? I have a general rule whenever I'm programming a tool or doing a particle system or a material is if my tool requires human discipline, like if the person that I end up giving this tool to needs to be very disciplined to get it to work right, it's not going to work right. I just assume whoever's going to use this is going to screw it up somehow. So this is how I'd fix it. I'm going to go back into my particle system here, my initialized particle, my particle lifetime, and I just want this to match the length of my particle system, right? We have this emitter state where we're saying this loops every 4 seconds. Okay, well, I want this lifetime to be 4 seconds, to be whatever I set the length of my particle loop to be. I'm going to see if there's maybe a property in here. I'm just going to search for loop and see what happens. Here we go. Emitter. Current loop duration. Right? Select that. Now it will always be this, like the lifetime of my particle will always be the same as the kind of loop duration of my particle. Yeah, and that's basically the gist of how you kind of create just like more interesting and interactive particle systems and materials. And one other thing I'd probably fix is this gets really kind of skinny towards the end, which I'm not crazy about. So we have this beam width in our particle spawn. And you can see our beam width is controlled by this curve, right? So the profile of it is controlled by this curve where it's skinny to start, it gets thick, and then it goes back to being skinny again. Just going to move this up a little bit so that it kind of stays thick towards the end and see how that looks. I'd say that's looking a little bit better. Probably make our sparks a little bit nicer. So I'm going to open up my sparks emitter again. For my shape location, I'm just going to bring the sphere radius down to like 10 seconds or 10 centimeters rather, because our sparks were kind of exploding out from a very large area, maybe 20 centimeters like so. And we have this add velocity here. And that actually looks fine. I'm not too broken up about that. What I might want to do is make these glow a certain color, right? Might want them to be the same color as my beam. Would be a good idea. So in our initialized particle here, we have this color mode right here. We can just grab our parameter. Actually, no, we can't because I'm in my emitter right now. You can only grab parameters in a system. Not sure why, but that's the bottom line, is that's kind of what you have to do. So I'm going to go to my sparks here, initialize particle and color. And what I want to do is multiply. So I'm doing the same thing. So I'm going to use a multiply linear color, set my linear color to match my beam color, and set my scale factor to a float so that I can just set this to like a single easy value. Okay, I can set the defaults of my parameters here. I'll set this to like 1,000. So now if I look, you can see that my sparks match the color of my beam. For some reason, they're not quite flying out yet.
Like spawning, so there's sometimes like, 5 of them going on, and sometimes like 2. I did a random floating range between 0 and 250, but I swear it kind of just like builds.
So you did that for the spawn rate. You'd probably want to mess with the spawn probability. So spawn probability basically. So let's look at my preview here. So I'm spawning 1,000 with a probability of 1. If I set this to like 0.2, you can see it's spawning like it just changes like basically it's saying, well, like every second I want to spawn 1,000, but we're only going to do that 20% of the time, right? Because is this kind of the effect that you're looking for? If you press F, it'll frame the particle in your preview. Problem. And there is kind of one last issue that I'm seeing. And I don't know why, but it seems like I'm going to search for collision and see if there's anything. Sim target, CPU sim. For some reason, when I spawn them in a very small area, so my sphere radius is 10, it kind of like they don't really they seem more like a jet of sparks rather than an explosion of them. Not sure why. If I set this to like a value, a sphere radius of like 20, be my guess. Seems to look a little bit better. Okay, that's all the time we have for today. Yeah, really the remainder of this class, I think next week is kind of the last. Again, it's not even necessary for your assignments. We're going to go over importing audio to help like build soundscapes and stuff and add, you want to add like car noises to driving and stuff. We'll go over that. After that, the remainder of the class is just kind of review work periods for your assignments. Me being here to kind of just like demo more advanced concepts, animations. We can go deeper into animation state machines and rigging in Unreal Engine. And maybe like rendering cinematics, if you're interested in doing that, we can take a look at that. Want to make your landscapes look nicer, we can try and really like push the landscapes to the next level. Aside from that, it's just like fun stuff. If you're interested, come, we'll do some more advanced stuff. But yeah, at this point, all of like the actual required content to finish the class is covered. Okay. So it's really just review sessions from here on out. We'll do audio next week. And then it's just if there's anything you want to try and add to your game, we'll work through it and try and add it. Right. Because when are classes like done for you guys?
Earlier, it's just open class if we have questions for assignments.
Gotcha. Okay.